Okay, so something that we have been talking about lately is the trigonometric ratios. And guys, this is basically a way of describing the relationships between the sides of right triangles, giving us kind of an ability to find out certain sides of triangles based on given information that we have. So you can pretty much do this with any triangle that you can do the Pythagorean theorem with, as long as you have an angle. And that's the new thing that we're talking about is that, okay, well, we're given an angle, and this angle is going to be called the reference angle. And if you've got a right triangle and you know one of these two angles here that isn't the right angle, okay, so if we're given a reference angle and we know what it is, we know that the side that is directly to the opposite side of the triangle, well, we're going to call that the opposite side. If we're talking about trying to find sides of triangles given certain angles, the other thing that we always know about right triangles, we know where the hypotenuse is because we know where the right angle is. So if we know where the right angle is, we know that directly across from that right angle, so up here, right there, across from the right angle, that's where the hypotenuse is going to be located. So we can label this one as the hypotenuse. It's the longest side of a right triangle. There aren't ever going to be any other sides on this right triangle that are going to be longer than the hypotenuse. So you know which one that is based off which one's the longest side. Um, Otherwise, the last thing that we need to find would be the adjacent side. And we'd be able to tell what that is because it's not the opposite side or the hypotenuse. It's connected to the reference angle, but it's not the hypotenuse. So it's connected to both the reference angle right here and the right angle over here. So that's how we know that this would be the adjacent side. Okay, so the first of these three types of trigonometric ratios we can talk about be the sine ratio. That's when we have, we can use the sine ratio whenever we have a reference angle, of some amount of degrees. Let's say 40 degrees. Okay, and then and let's say that in our problem set that we're trying to figure out, we're trying to find a missing side that would be labeled x over here, and we're given something like 15 for the hypotenuse. Okay, well, based off this information that we have here, think about what we are looking for. We are looking for a side that's over here, and we know that the reference angle, which is 40 degrees, is located in a spot so that, the side that's opposite to this reference angle is the unknown quantity that we're looking for, and we'll call that the opposite side since it's located opposite to the angle. We all know that since this is the right angle right here, this would be the hypotenuse, and we know that the hypotenuse would be 15 of some sort of unit that we don't really know what it is right now because it wasn't specified. We could say it's centimeters. Okay, truth is that these are both going to be centimeters, and since we have a ratio, it doesn't really matter what it is. They're both going to cancel out anyhow. So anytime that we have these two figures in the ratio here, we're going to be able to set that equal to the sine of whatever our reference angle is. So when we put 40 into the calculator and calculate the sine of it, we get a ratio, and it's going to be in decimal form. So as long as we set up our equation the right way, which is shown right here, that we'll have the sine of an angle, and that's going to be equal to the opposite side divided by the hypotenuse side. So if I were to take whatever x equals, it's a mystery at this point. We're trying to solve for it. But if I use that value that x actually is and divide by 15, we're going to get the same decimal output that the calculator is going to give me when I put in sine 40. So basically, whatever calculator you're using, you're going to need to get comfortable with it. If you're using an iPhone calculator, you're going to need to type in that 40 first and then hit the sign button. If you're using TI-84, like the ones that we have in class, you need to hit the sign button and then type in 40 into the parentheses. Either calculator that you wind up using, when you type this in there, you're going to find out that the sine of 40 is 0.6427 8, and it would round up at this point. So after 8, we'd have another 7. So we would round up to be a lot of decimals to use right now, and so we could round to that many. We'd be fine with that. So that would all equal the same ratio that we had before with the opposite divided by hypotenuse. So we know that that would be x over 15. So given that, what students are going to need to be able to tell what to do now is that we're solving for x. We're trying to find what value of x makes this equation possible. So out of the very, very basic fundamentals of algebra that we've been working with a long time, the way that we would get this exact setup situated so that the x is by itself is that we would have to get rid of that denominator, which is a 15. And the only way to do that is to multiply everything in this equation by 15. When we do that, that's going to make sure in the denominator of this fraction gets canceled. So that will be gone once we multiply this whole fraction by 15. And so what that is going to mean is that we're going to multiply the other side of the equation by 15, and that is going to give us 9.6. So in this particular example, x would be 9.64. That is the decimal that I'm getting out of my calculator right now. And so that is what the answer would be. I mean, plain and simple. If we're using the units of centimeters, and there you go, 9.4 centimeters. There's also other types of problems where, we're using the sine ratio, but we have a situation where the unknown quantity is going to be the bottom of the fraction. So I can show you the times that you can identify where that's going to happen. So let's say we have another problem where we have, we're looking for the side of a triangle. Let's say we're looking for the hypotenuse this time, and that we have a side length of 10 over here, which we would be able to identify as the opposite side to this reference angle. So we know that we're going to use, so if we see this out in our problem sets, we're going to know that we're going to use the sine ratio. And so that we know by now that the way we set this up is we always have the sine of, whatever angle we're working with over on this side, and we have the opposite divided by the hypotenuse on the other side. So in this case, since we have opposite on top and hypotenuse on the bottom, we have 10 divided by x. Okay, and that's going to be, since we know that the reference angle is 35, that's going to be the sine of 35. So if we type in 35 in our calculator, we take the sine of 35, making sure we're in degree mode, we're going to find out that the sine of 35 is actually 0.573, and this next decimal, 6, if you must know, gets rounded up. So we're being nice and accurate, using plenty of decimals. And what we're going to do now is something a little different. Because you guys need to know by now that whenever we're trying to get rid of a denominator, or we're trying to get x by itself, we're trying to manipulate fractions. If you're trying to get rid of a fraction, you're trying to eliminate the fractions so that you just have a line full of whole numbers, you're going to need to make sure that you multiply through by the denominator, whatever it is. When that's a whole number, great, it makes things a little easier. When it's a variable, it just adds an extra step to the problem. But the underlying principle is the same, that we're always multiplying by the denominator to make sure that's what gets canceled away. Okay, so what we're going to do here is multiply by x. And that's going to get rid of this denominator right here. That's going to cancel this out. This will definitely be canceled. Okay, so if that's gone, then what we're left with is 0.5736x equals 10. And in order to get x by itself, we need to divide by whatever's in front of x. So that would be 0.5736. Again, this is super basic algebra principles. And what's honestly frustrating me a little bit is that I'm seeing a lot of students struggle with this concept, even though it's tried and true, something that we've been doing for a long time, and it's a very simple example. I could give you guys 2 and 3 step algebra problems, and most of y'all could get it once you get in the right mode. I know we're talking about geometry right now, but when we're using algebra to solve for quantities that are in our geometry problems, those same rules of algebra still apply. And we really need to make sure that we're not forgetting that. We really need to make sure that we're formulating frames of mind where, this becomes second nature to us. And for some of you, you have. And so if you have, and, I'm preaching to the choir right now, feel free to relax. I'm obviously not going off on you. I'm just bringing awareness to the fact that we all need to make sure that this is happening, that we're thinking in these frameworks of mind, so that we don't have to keep struggling on things that none of us should really be struggling on. So basically, doing all that, what we've done is we've canceled this out in front. So what we have as our grand total is x equals 10 over 0.5736. X equals 17.4. All right, so that's how we deal with problems when x is in the denominator. Turns out that we want to cancel that out, which yields that, basically we're taking whatever it is right here, and we're putting that in the denominator, and we're bringing the x out to where the sine 35 once was. We're basically swapping the two locations, but I just went through the principles of algebra that show you why that's happening. Okay, so problems involving cosine are very similar to sine problems. Similarity being that we are still dealing with a hypotenuse that's we may have that as a known quantity, we may have that as variable we're looking for. We do know that we are dealing with a need for discovering either an adjacent side or a hypotenuse side to in a right triangle where we know a certain reference angle again. So let's say we've got let's say we have a right triangle problem that looks like this, where we got a 30-degree reference angle, and we're asked to find a side that's adjacent to the angle, but it's not the hypotenuse. So I want you to kind of begin to be able to identify that if this is the reference angle that we're looking at, we can see that we have a hypotenuse here of 12. It's across from the right angle. And we know that our reference angle is always going to be touching the hypotenuse side over here. Oftentimes we're going to have another side of the right triangle where the reference angle is also touching. So every time we're going to set these up same way. We're going to have an angle. We're going to take a trigonometric function of that angle. This time we're going to do cosine. And we're always going to put the angle in the parentheses. Then we're always going to take the proper sides on the top and bottom of our trigonometric ratio. And if we're ever dealing with cosine or sine, we know we're dealing with the hypotenuse. If we're ever dealing with the hypotenuse, we know the hypotenuse goes in the bottom, in the denominator. So that leaves us that the adjacent side needs to go in the top, and that would be x in this case. So we've got another one of those scenarios where we've got a whole number in the bottom, in the denominator of the fraction part of the equation. And so that makes everything real simple on us. We just need to multiply by 12 to get rid of it. So that way this 12 has been canceled out. And all we need to do now is solve for the cosine of 30 in our calculators, which is 0.866. And we're going to take that quantity and multiply by 12, giving us our unknown quantity x. So we're going to take that in our calculator, multiply by 12, and we got 10.39. Okay. What about also we might have